By 2027, we want to be the fastest electric autonomous vehicle in the world, period.
Even with lesser resources, there's definitely a lot that you can do if you have the determination.
The way our team works is essentially kind of like a startup. You have to pitch to people, you have to raise funds, you have this really good idea and a project in mind that you want to build, and you have to convince people that it's worth the amount of money required.
Hi, my name is Amrit. We've heard that IIT Madras is the best place to build. So we've come down to the Sudan Shankar Innovation Hub. We want to meet some people. These are builders. We want to talk to them about their work and also ask them what makes IIT Madras the best place to build. Hi, welcome to the Best Place to Build podcast. Today we are sitting with the Raftar team. It's a little different from the normal podcast we have where we called professors or alumnus who have made startups. This is an actual student team, one of the oldest student teams. So let's get started. Hi, Aryan.
Hi.
Welcome to the podcast.
Yeah, nice to be here.
Can you start by introducing yourselves?
Yeah, so my name is Aryan Varma, and I am a BTech student in the metallurgy department. So this is my final year right now. I have one semester left, and currently I am team captain of Raftar Formula Racing.
Okay.
Yeah.
So what is Raftar Formula Racing? In fact, before you say that, can you tell us what is student formula racing?
Okay, so FSAE is basically a type of competition where student teams from different engineering colleges around the world are tasked with building a high performance race car. This can be, depending on which competition you're taking part in, this can be different types of powertrains. So one is a combustion based powertrain, which we've been for a lot of our history. The other is the electric vehicle. So, with a battery pack and then an ECU and everything. And then there's a third level where some teams in the world have now shifted to driverless. So if you're a driverless team, you get bonus points. So basically, this team works throughout the year in designing and manufacturing and testing a full race car prototype, and then we take it to competitions both in India and around the world, and then we race with the other engineering colleges and see who comes out on top.
Okay, so are there competitions in India for this?
Yes, so there is one main one called Formula Bharat. So this used to happen at the racetrack in Delhi. Now it happens in Coimbatore. This has been going on for quite a long time. Recently, they also incorporated the electric side of things. So when we started off in 2012 as a combustion vehicle. And from there to 2020, the competition was fully combustion. And then electric has just started out, and then COVID hit, right? So we had a 2-year break where no one was on campus. We couldn't do much physical stuff. So we thought, why don't we take this time and work on designing our electric powertrain, because, the world is moving and we should also evolve with it. So why not just do this big step? So we took 2 years, we designed our electric powertrain, and now we've been competing in the electric category, Formula Bharat.
So this competition in Coimbatore, which are the colleges in India which take part? Just give us a sense of it.
Okay, so there are around, in total, I'd say 40 to 50 teams, including combustion and electric. Last year in the electric category, there were around 25 to 20 teams. This year there are more. So this will have all the IITs. So IIT Bombay, IIT Roorkee, IIT Delhi, Kanpur, Kharagpur. Slowly, all the other IITs are also, building their own teams. I think Hyderabad just started their team a year ago. So all the IITs are there, and then different colleges from all over India. There are a lot from Pune. COEP is one that participates. There's another from Pimpri Chinchwad. There are a couple from Delhi and North India as well. So it's a completely national competition, and almost every big college in India participates in this.
Okay, interesting. So, and globally, where is it held?
Globally, it's held in a lot of places, both in America and Europe. So every country in Europe has its own competition. So there's an FS Netherlands, there's a Formula Student Germany, there's a Formula Student Austria, and here Formula Student Germany is like one of the biggest engineering competitions in the world, first at a student level. So this year we managed to compete in the electric category there. So there were around 80 teams overall, and it's crazy. The current team winners, the competition winners, also hold the world record for the fastest accelerating vehicle. So I think they did 0 to 60 miles an hour in, I think, just less than a second.
Which university is this?
This is ETH Zurich in Switzerland.
Okay. But tell me something, like, it sounds interesting, and there are student teams from different colleges who are competing both at national level and international level, right? And the umbrella body is FSAE.
Yeah.
Okay. So why should a student do this? Like, if I were a student now, why would I want to be a part of a student racing competition?
So there are a lot of aspects to a team like this. The first thing itself is, and I'm sure this applies to any other team that does what we do. It's a team full of like very passionate and ambitious students, right? So it's something we look out for when we're recruiting as well. And you get to learn a lot hands-on. I know there's, usually, especially at IITs and different engineering colleges, we have really good courses, but then we don't get enough chances to apply that somewhere. So, learning how to sort of actually make something. So this is one really good place where you can learn that. Designing something on a computer, then manufacturing it, then learning how to test it, and actually validate that, okay, what you've designed for really worked. And that feeling, right, that you get when you saw something on a computer and then like suddenly it's in front of you and it's working. I think that's why we even joined these engineering colleges in the first place, right? So that's something that is very rewarding. And secondly, because this is a competition team, the stakes are high, and the environment is intense. So even at a personal level, there's a lot of growth that you can see in each of the student members from the first time they join to when they've graduated from the team as a core team member. So there's a lot you can learn. There's a lot for you to grow as an individual as well. So overall, really nice place to be.
So you're saying that from an engineering student point of view,
Yeah.
the courses can become very abstract and quite distant.
Yeah.
And this is a place for you to sort of feel the engineering in a very close way.
Yeah.
And maybe feel the whole cycle from design to manufacture to actually on the field.
Absolutely. And this skill set that you develop here, it helps you in your future as well. So, if you apply for research internships, you can, really just shoot for the stars, because you learn how to design parts, how to analyze them, carry out FEA and stuff like that. And
Wait, what is FEA?
FEA, finite element analysis.
okay.
So it's basically seeing how strong a part is, how long it'll last. And this skill set, if you get very early on, you can build on top of it, and then try something really niche in a research project, which someone might not be able to get into immediately, but because you have that experience, it's really simple.
So once you finish your undergrad, a company that's recruiting you, or a master's program or a PhD program that's looking for students to join them, would value that skill set that you came through and Formula project, or a similar project which involves a lot of engineering.
Yeah, because even these research groups, they in the end have projects, right?
Yeah.
And if you don't learn this here, you'll eventually have to learn it there, and it'll take time there.
Yeah.
So this is a good way to, instead of just focusing on coursework, add this as well, so that you save a lot of time when you're working on something for yourself.
Right.
Understood. Yeah.
Okay, can you just tell me, you said students design, manufacture and test this whole thing. It sounds, I mean, like, it sounds a little like a fantasy. Right?
Yeah.
So are there faculty members involved, or are there, how do you get at a second year, first year level and start designing a formula car, it's quite, I'm guessing it's quite hard, right?
Yes. So there's a lot of learning involved. There's so much actually. So I was part of the suspension team, right? And I joined towards the end of my first year. And I had no idea about what a car does, right? I knew how an engine worked. I knew, what an airfoil is. But beyond that, I didn't know what's involved in like the engineering aspects of a car.
Yeah.
And then I joined the suspension team, and it blew my mind that the amount of theory that's there just in the tire compound, and like the orientation of a tire on a vehicle as it's taking a lap around a track, it's crazy. And
So did you do a coursework to understand this, or was there like a self-study?
there's a course as well,
Okay.
from in the ED department, but a lot of it is also just self-study,
Okay.
looking up. There's different YouTube channels, looking up research papers, and we have fortunately a big faculty support for this as well. IIT Madras is probably the only institute that has this whole structure, CFI, with all these competition teams. So we have our own faculty advisor, Professor Satyanarayan Seshadri, who's been with us for quite a while now, and he's seen our EV development. We also have CFI's faculty advisor, Professor Prabhu. We have the manager of the Office of Nirman, Nandini ma'am. We have for Raftar, we have our own advisors. Anytime it comes to something technical that we're trying to look into, something, if we're trying to do something novel and we need some advice, we go to a lot of different professors. Professor Karthik Atmanathan, who's a visiting prof in the ED department. This was Shankar Ram sir. We have alumni from the IIT Madras, association, that help us, reach out to different alumni and try to raise money, because this is not, a very simple aspect on that side as well. So,
It sounds quite expensive, actually.
yeah, Session Ram Mohan sir, who founded the IIT Madras Foundation in the US, Vasu Guru Swami sir, and a lot more. So,
So tell me something. So I'm guessing also that you're a 12-year-old team, right?
Yeah.
So is there a lot of internal body of work that you work on, or every year you start again?
so I won't say we start from scratch. We do have a very nice structure for this. So, basically, what we do is every year we build a car, we test it throughout the year, we take it to the competition, see where it falls short or where we can improve on. Based on that, right after the competition, we define the goals for the car and the team. So these goals don't necessarily need to be just for the competition. They can be more broader goals as well. And after we design those goals, we say, okay, suppose we want to reach a one particular lap time in some dynamic event, right? How do you do that? What part on the car, what aspect of the car do you need to change to achieve that? Do we need to change our battery pack? Do we need to optimize the weight of the car? So all of these aspects we look at and define, okay, if these are our goals.
Sorry. I'm missing a step here. So in these Formula SAE events, what are you judged on?
So we're judged on a lot of things. So there are different events at the competition. So there are dynamic events, obviously, where
The dynamic event.
dynamic events is where you race the car. Again, your lap times are compared to all the other teams, and you see who has the fastest car. But there are other aspects as well. There's a cost event where they see how much money you put into this and how efficient you were in that aspect. You can't just be prodigal. You have to be able to justify every aspect that's on the car.
Okay.
And that's
So I
something.
can't over-engineer the car because then I
Yeah.
won't.
And that's something that they check in the engineering design event as well. So that's where they really check the justification for every part on the car, why it's there, what our ideology was behind designing it, how we managed to test and validated this.
Okay, so there's a design event, there's a dynamic/race
Yeah.
event, and there's a cost event.
Yeah, and there's another 75-point event called BPP, which is the business plan presentation.
Oh.
So this is kind of like our competition Shark Tank, sort of. So we have to basically take our car, treat it as a product, and then try to build a business around it. It can be anything. It can be, AR-based go-kart tracks, or it can be something completely different. I think one of the teams built a whole reality show around this and presented it to the judges. So the judges will act as investors, and you have to really pitch for them. Yeah.
All business plan competitions are now Shark Tank.
Yeah.
Can you tell me, so each of these things are on EV train and combustion train? Okay, that's very interesting. So it's not like one prize, it's a bunch of prizes.
So the combustion category has its own set of prizes, and the EV category runs parallel to that.
Okay. And you mentioned that it feels like it, and it feels to me also like as you're speaking that this is an expensive affair. Does the institute pay for all of this?
Yeah, so we get a certain amount of funding from the institute itself, and then we use that to build the car. And then with the help of the institute, we reach out to different companies and try for sponsorships, and then try to raise as much as we can on our own as well. Because the more cash we have, the more flexibility we have in terms of what material we're using, what we're doing on the car. And then still at the last moment, when there's some amount left, we go to our professors, Prabhu sir, Satya sir, and they manage to help us find some last moment funds, and then we still get to.
Okay, interesting. And I saw that your jersey has Ather written on it. So is Ather one of your sponsors?
Yes, so Aether has been a long time sponsor. It's been 2 years now, and they help us both sides, monetary and the design aspect. Right now, we're building a battery pack which is about half the weight of our current battery pack, but still has double the energy. So we got a lot of inputs from them about the cooling aspect of it, the integration, how to manufacture this properly. And we interact with Aether very well, and it's really beautiful to see that aspect of it.
Of course, there's a deeper story here because Swapnil, who's the CTO,
Yeah,
and Arun, who was one of their first
Yeah.
product head was a Raftar team member, right?
Yeah.
They used to be, like Swapnil was the head of
Yeah.
Raftar
Yeah.
maybe about 10 years back.
yeah.
That's quite cool, right?
Yeah, absolutely. And I feel that throughout my 3 year journey in the team, I sort of realized that there are a lot of um, sort of inferences that you can take, and the way our team works is essentially kind of like a startup. You have to pitch to people, you have to raise funds, you have this really good idea and a project in mind that you want to build, and you have to convince people that it's worth the amount of money required. Then you make it, then you have to really test it, make sure it's a product worth showing to the world.
Yeah.
And then you take it to these competitions and you prove yourself.
Yeah.
So there you learn so much, even from, like, if you keep the technical side aside, if you look at just how to raise funds, what different opportunities are there, what different pockets can you look into if you have a good idea and you really want to build on it even after graduating. This kind of experience gives you a lot of exposure. And that's how, not just Aether, we've had a couple other startups as well, Terrero Mobility, Exponent Energy, two of our recent.
Exponent, you can't be counted twice. Arun, who was the product head at Ather, now runs Exponent.
Yeah, that's it. But again, it still comes from this.
Yeah, sure.
The exposure that you get in the team, right? So
Yeah, I do imagine that not just from Raftar, a lot of the CFI clubs have spawned startups.
yeah.
So I do imagine a CFI mafia
Yeah.
maybe in 5-10 years.
Yes.
I guess it's already there, but it's quite weak now.
Yeah, I mean, it's still at the initial stage. Yeah, we have
In another 5-10
a few of my seniors as well have started something. They're working on a product, and let's see how that goes. But yeah, this is a great experience to get into that kind of stuff as well. And yeah, the exposure you get is.
It's amazing. I mean, it's not just not just founders, but a lot of the early Ather employees are also Raftar members.
Yeah.
I have heard this story from the lead designer in Ather, where he talks about he's from IIT Bombay, IEC, and he talks about how he was visiting IIT Madras maybe in 2012 or something, and he met Swapnil and Arun, and he suggested to them that he would design the outer body, and eventually when ended up designing joining Ather and then designing the Ather bike. but his name is Shantanu, and he has this very poignant moment where he describes him coming to CFF for the first time, and sort of walked in, and it's this hot summer Chennai day, and it's really hot, and he sees these bunch of people working, and he says, I could see someone like hugging the robot he has built and sleeping, probably because he was working all night in front of a fan.
Yeah.
And just emotion that he was talking about. And it's quite like that, right? Like it's a very high passion driven team. That's damn cool. Before we started, before we started this podcast, you were also explaining to me the organizational structure. So I'm just going to pass this on to you. Maybe you can draw it for me
Okay.
and the audience so that we have a sense of how this actually works. Here you go.
Okay, so we have Raftar Formula Racing, which is the whole team, and it's divided into two parts. One is the chassis, and the other is the powertrain. So these are the two main divisions that the team has, and all the sub verticals fall into this sort of these two envelopes. So under chassis, we have three main subsystems. One is the vehicle dynamics and drivetrain. This subsystem handles the design of the suspension, the steering, and the brakes of the vehicle. Then
By the way, I want to tell you when you were talking about suspensions that when I was in institute, I was also studying suspensions.
Oh, really?
Yeah.
Okay, what aspect?
I don't remember. I think at that time we were trying to use some algorithmic ways to figure out better suspensions, but it didn't go anywhere because obviously CFA was not there. And as you said, I felt while I was doing that work that it was very textbookish. You do something on a computer, and then it doesn't get done.
Yeah,
You just have like a graph outputs.
Yeah, and stuff like this. It's sort of like a very rewarding feedback loop, right? You learn something, you apply it,
You saw it work,
you see it work,
and then you go back
and then
like,
that gives you more ideas to learn even more, and then you apply that again, and then you just keep on going and going. So coming back to this, we have we have the aerodynamics department. So this is something that would be very familiar to anyone that follows F1. We have
correct, because we've seen the
the front wings, the rear wings, DRS, the side dips,
the downwash.
Yep, the downforce as well. All of that is taken care of by the aerodynamics department. And then we have frames and composites. So this subsystem has a very important role in the chassis. So they basically make sure that the core structure of the vehicle is safe in case the car crashes by if something bad happens. So right now, for example, we have a steel frame. It's around 30 kilos, which is a significant improvement from last year, where we saved around 5 kilos at least. So right now this is there. But then if you look at F1, they have carbon fiber monocoques, which is basically a shell made completely of carbon fiber, much lighter than a steel frame. So that is our end goal as well, and we are working on that.
Right. You spoke of goals earlier.
Yeah.
So some year the team might decide, let's move to carbon fiber, and then
So
that will be their big thing of that year.
So we're trying to replace as much steel on the car with carbon fiber. So not just the steel frame, even our suspension linkages, which are the rods that connect the wheel to the chassis, those are steel. But we're working on prototypes to have CF rods, and then our drive shaft as well, completely carbon fiber. So all of this we're designing and testing right now, and hopefully by the end of this year we see that in motion. So coming back to this.
But that's how engineering works, right? Maybe it's not very clear in the beginning, but a student who enters will be working on reducing 35 kilos to 30 kilos. And there's so much work that goes into that and so on. And it's not like he's doing everything. It's a whole team. And go on. Sorry. I don't know why I said that.
No, but that makes sense, because it might not seem much when you talk about the numbers over 1 year. But then if I compare our car right now to the car it was 3 years ago, huge improvement, right? Completely different battery pack, at least around 40 to 50 kilos lighter overall. And then that's where we're talking about huge performance boosts. So it's an iterative process, and that happens because it takes time. So The powertrain is divided into two main parts. One is the battery pack. So these guys have kind of a mixed role where they're taking the structural integrity of the battery pack into account as well. All the cells need to be, very well assembled. In case of an impact, nothing should happen because, there's a driver in there and that's a life as well. So that aspect's taken care of by the battery pack team. Additionally, even the top layer, all the electrical systems or BMS stuff like that, that's handled by the accumulator subsystem. And then there's a separate electricals vertical. So these guys take care of all the safety systems in the car, making sure our car is safe enough to be running in case there's an error. Is it being reported? Is the car being stopped in time? All that aspect is taken care of by the electrical device.
That's very interesting. Actually, I was just thinking about it as you were saying, and we met. By the way, we met Professor Prabhu and Professor Satya on the podcast.
Okay.
Professor Satya Sheshal. We also met Professor Satya Chakravarti, and he was talking to us about how battery packs also have to sort of deliver acceleration, and that will be a big concern for you, right?
Yeah.
Like the requirement on the battery pack for you is very different from the requirement on the battery pack for say an EV.
Yeah, absolutely. And that can lead to, a lot of other things, especially in a place like Chennai where everything's so hot. The cell temperatures is something that is so important, and you need to do so many tests just for the cooling of the battery pack. Where you have fans, how the side pods are channeling the air being caught by the car into the duct that we have, and then how that cools the cell tabs, making sure the cells are uniformly cooled so that there's no varied cooling in the battery pack. Otherwise, as one specific part would degrade faster than the rest, and then
Cool. So this is your entire engineering team.
yeah, this is our team.
How many people will be there?
Right now around 40,
Okay.
and every year we recruit 20 to 30 students.
Okay.
Yeah.
In each of these teams.
Yeah.
Are there other teams which are looking at the management side of it, the fundraising side of it? How does that look?
Yeah, so we have a sponsorship team as well, that handles all the events we do. For example, when we built our first EV, we had a full car launch, and then we called the media, and the director was also there. And that was a big moment for us. Another thing is, in managing our relations with all the companies that we interact with, both from a technical perspective and the funding that we try to raise. That aspect is taken care of by the sponsorship team, interacting with different alumni, reaching out to as many people as we can, trying to see if there's someone from who's an IIT Madras alumnus willing to help us, because alumni love this kind of thing. So that aspect is taken care of fully by the sponsorship vertical. The core team, which is the final year students, they also sort of dabble into this, and parallelly they handle the logistics. Like I said, we take part in Formula SAE in Germany, which is a completely different country, and we have an electric powertrain. So shipping a battery pack is not easy. This is something we experienced this year, but all the logistics, it has to be taken care of. Like, we felt that us being involved in that helps us out in the sense that we have a stake in what's being shipped, right? So we're able to drive this faster. We also learned a lot about, how it works, the logistics side of things. And, hopefully over every year it sort of gets streamlined. So there's a lot to do on that side as well. And that's what the core team takes care of.
Nice. This is great. Aryan, I want to just also compliment the fact that when we started this podcast, you mentioned that you're part of a larger team and you'd like to split the interview with your teammates.
Yeah.
Amazing. That's great.
Yeah.
So now who are we meeting next?
We're meeting Ankith. He's one of my batchmates, and he's the aerodynamics lead of the team.
Hi, Ankith. Welcome to the podcast. I heard some part of this whole puzzle from Aryan about how Formula Racing works and how the Raftar team is structured. I want to start out by asking is, Ankith, you guys put in so much effort. There's so many people involved. There's money involved. There's a lot of repetition and all of that. Do you guys actually win?
Oh, we definitely do. So I mean, the entire team, like all the work that we put in, everything that we we're passionate about over here. Like, of course, we get to learn a lot of stuff, and it helps you a lot in the future. But then, in the moment, all of us just want to win because, like, you've put in all the effort over the entire year. You've designed all these parts that have gone on the car. You've spent a lot of hours manufacturing them. You've seen the car being tested. You've had lots of highs and lows throughout the year, and it all culminates down to those final few days of the competition, which defines pretty much all the work you've done across the entire year. And everyone who comes there is just very competitive because
Is it?
yeah, I mean, you have teams from all over the country in the national competitions. You have teams from all over the world in the international competitions. You have teams from various backgrounds, different kinds of resources and backing, and it does get fed.
Do we have like arch rivals?
It varies year to year. So like sometimes some teams would choose to go to an international competition or like a national competition, and you might not see the other teams every year.
Oh, right,
But
of course.
so because there's like so many competitions across the year, like Formula Student is like this massive community, and like pretty much every European country has their own version of a Formula Student competition. So you probably don't meet teams every year, but I wouldn't say it's a rivalry. Instead, it's more of like a healthy competition. Like even at the competition now, let's say for example, apart from our car fails, you can always be sort of not too shameless to go and ask a team from like another college and ask if they have a spare part. Like,
Okay.
and they'll be happy to help because at the end of the day, we're all here. We're all competitive with each other, but we want a healthy competition. We want the best team to win, not we don't want luck to like rule someone out.
Right.
And of course, like even after the competition, we have all these wonderful conversations with not just the judges, but also team members from the other teams on why they chose a certain design or like why they did something that they did and like what we could do next year. A lot of the designs that you see on our car or on other teams has in some way been inspired or influenced from the other teams at the competition.
I noticed very clearly that you have avoided naming any other institution, but okay, I will not push you on that. Give us an idea of the history of Raftar.
Okay.
And also, I think it intertwines very well with the history of CFI. So,
Yeah.
give us a sense of the legacy.
Okay. So Team Raftar was the first competition team from CFI. The team started attending competitions for the first time in 2012, and we've been building cars ever since. Pretty much every year, apart from like a couple of gaps like COVID and then another small gap in 2015. But pretty much every year we've been building a new car. And the first competition that the team attended in 2012 was FSUK, and it was a humble beginning. The team definitely learned a lot back then, and then 2013 was a bit more successful. We went to Formula Student Germany, which is the top competition worldwide for Formula Student, and we attended the dynamic events then. So it was a huge step back then, and then we've been working tirelessly ever since then. And 2016 was, I think, the first year where we had a podium finish at the competition. We finished third at the national competition back then, and that was a great year. It was the first year that the team had the iconic black-green livery that Raftar's become synonymous with.
Also, is the background for our podcast.
Yes, is also the background for our podcast. So you can see, it's probably blurred, but you can see the old nose cones of all our cars. And on the very left, you can see the white and the sort of silvery bluish nose cone. Those were the early ones. And the third one is the 2016 nose. That was the first black green.
293.
The one that says 10, it's hidden under the banner.
Okay.
And everything since then has had, black, green, and white on the livery. And 2016 was a fairly successful year. We had, lots of stories, but we get to that in a bit. But then from then on, we've been like consistently performing at the top. We've been on the podium pretty much every single year. And all of that built up to 2020, which was arguably our most successful year in the history of the team. We were overall champions. We beat our own points record that we set in the previous year once again in static events. And we won the championship by
Static events are cost, design,
and business plan.
B.
So we won the championship by a huge margin that year. and that was the first championship, the first national championship that we won. And then after that, COVID hit, and everything went virtual for a few years. And we defended our championship virtually. We won in 2021 and 22 as well. So 3 years of successful winning, and then that's when we shifted electric. So we decided, the world's shifting towards electric, the world's going green. So why not make that shift right now when everyone's taking a break, and we have some extra time on our hands. Everyone's sitting at home, and you have a lot of time to put in a lot of thought into building a design so that you can manufacture a new fresh electric car when everyone comes back. And that's what we did. 2022 we built our first ever electric race car, and 2023 was when we participated in our first electric competition. It was Formula Bharat, and we managed to finish third in our first ever electric competition, which was a huge step at that time, because you have a lot of Indian teams that have been electric for many years before us. They've had a lot of time to perfect their designs, year after year, and then to just go at your first attempt and then stand on the podium. That was a
I just realized that we are recording this just before Formula Bharat,
yes,
and the podcast will be released after.
yes.
So we will know whether
We will know what the results will be. The audience will know what the results will be of our third electric competition.
Yeah.
Hopefully we win. So yeah.
Give me a sense of, I understood what you're saying, but give me a sense of if you go to Formula Germany,
Yeah.
how hard is it to get a podium finish?
It's very hard, and that's for a number of reasons. Firstly, you have a lot of restrictions in you're traveling from all the way from India to Germany. You have to ship an entire car and all your tools and everything, and there's a limit to how much you can carry. You're not on your home turf anymore.
Yeah.
And the international teams there, they have a lot more resources. They have a lot more funding. They've been in the game for a lot longer. Like Formula Student has been a thing since before the 2000s, and there've been a lot of teams that have been here for a very long time, and they've been building cars for a very long time. So they have a lot of knowledge from the previous years, and it is tough, but we're getting there. Like
Fair enough. An European team, say from Italy or Switzerland, maybe simply having a Formula team for 25 years.
yeah,
Yeah.
Right.
And they may have moved to EV like 10 years back.
yep, exactly.
And also maybe sitting in India, we don't realize it as much, but in Eurozone, going from Switzerland to Germany is like going from Karnataka to
Exactly,
Bangalore,
exactly.
Chennai.
Teams bring, in fact,
You can simply drive down.
you can simply drive down. They have these massive trucks. I'll
Trailers.
tell you this. Yeah, I'll tell you this funny thing. So there's this one team from the Netherlands. They have an entire truck full of tools and like machines, and they come and they set up shop in Germany. And like any part that fails, they can just manufacture it on site and put it
That's
onto
so
the car.
cool. It's like a
That's so
vanity van
cool.
for the car.
Yeah, and and what's even more wholesome is the fact that they're not like exclusive about it either. They're very happy to help out other teams. So like for example, we had a couple of fasteners that we needed really urgently to like clear technical inspection, and we just went up to these people and we asked them for help, and they were very happy to help us. And that comes back to what I was talking about, how everyone is competitive with each other, but it's very healthy, and everyone's very happy with talking about stuff and like learning from each other, which is really nice. And in that sense, when you go to these international competitions, you get this insane exposure, where you get to learn from the top teams worldwide. You get to know about things that you've probably never even thought about, things that you haven't even thought were probably possible, but they've been doing for many years. And it's insane to learn about these things and then come back and then try these on your own car. And yeah, it's just an amazing learning experience.
Nice. So it's not like if you double the sponsorship amount, you would finish higher. It's not like that. It's like a body of knowledge that
It's
you
a
do.
body of knowledge for sure. I don't think resources are the only major thing, but they definitely do play a decent amount.
Sure.
I mean, there've been plenty of teams, including us, in the past where with lesser funding, we've done we fought at like for higher positions, even in international competitions. We've gotten podium finishes before. So 2017 in Italy, we were the first Indian team to win a dynamic event at an international competition. We won fuel efficiency, and I think we were even on the podium for the endurance event, which was a huge milestone at that time. And since then, a lot of Indian teams have gone on to participate and even do well at international competitions since then. So yeah, for sure. I mean, even with lesser resources, there's definitely a lot that you can do if you have the determination and the great.
But I get what you're saying. If a potential sponsor is watching this,
Yeah,
they should consider sponsoring both.
for sure. Yeah.
Yeah, not less. What are the other teams in CFI? How old are they, and what kind of work do they do?
Okay, so in terms of there's two different kinds of teams that we have in CFI. One are the competition teams, and then you have clubs. Competition teams are teams like ourselves. You have teams like Anveshak, Abhiday, Abhiyan, Avishkar. I hope I'm not missing any. Even Amog started recently. So you have all of these teams that are building prototypes or building models, and they're participating in either national or international competitions. And
Sorry, you rattled out a bunch of names, but what do they do?
okay, so
I mean, you don't have to feel like I'm pressurizing you to represent all the teams.
Yep.
But what are the students doing in CFI?
so all the students at CFI, I think everyone is here with the motive to learn to apply classroom concepts to build some kind of a real life prototype. So, for example, we've been speaking about ourselves for a really long time. But then, for example, let me take a team like Abhiyan, for example. They build autonomous vehicles, and so you take classroom concepts that you learn that are sort of at the center of software, mechanical, and electrical concepts. And you have students coming from a variety of backgrounds putting all of these concepts together to build something that is, very new and sort of something that's, revolutionizing the mobility space at the moment. You have teams like Agnirat that are building a solar car and are participating in endurance events across the Australian outback. You have teams like Avishkar that are building
Hyperloop.
Hyperloop.
Yeah, Helmet Suresh.
Yeah, so there's a lot of innovative projects going on at the moment. And I think as a student, as an engineering student, someone who's passionate about applying to or working in core fields or starting up to build something in a core field, coming and working at a competition team in CFI is probably one of the best things that you can do in your time in the institute, because it classroom concepts can only take you so far, right? Like you sit in a classroom, you listen to a professor teach, you learn those concepts and you apply them in an exam. Exams are controlled environments. There's not so much you can do with creativity. You know something and then you apply it to some new problem that you experience, but then that's about it. You don't really get to face the challenges that you can face if you were actually building a prototype, you were actually manufacturing it and like trying it out and learning from those mistakes. And it's not just that, there's like so many soft skills. You also have to worry about the funding. You have a certain budget that you have to work with. You need to reach out to sponsors and then try to get more people on board to like expand the resources that you have to build better things. There's just so much.
So
that
how
goes
many
on.
people end up being involved in CFI projects overall?
If I were to talk about Team Raftaar, we have about 40 students, and these 40 students come from varying disciplines. So it's not just like a lot of people have this misconception that you have to be a mechanical engineering student or an electrical engineering student to do well, but you really don't have to. We have team. So my the previous aerodynamic lead, my senior, he was from naval architecture, and he was in aerodynamics. We have people from say civil engineering working on the electrical part of the car. So the background that you're from really does not matter, because what really drives you finally is the passion to work. And in fact, you learn.
But I also want to point out that I think the name of the course is
Yeah.
very misleading. Like, it's not like aeronautical engineers only work on planes. They work on a bunch of things, right?
Yeah.
Like, a lot of them work on engines.
Yeah.
There's a lot of thermodynamics.
Yes. So it's it kind of comes down to the basic engineering concepts that you learn and you acquire, and then it's these fields just help you specialize in applying these concepts to something.
Yeah.
But the basic concepts that you learn are still more or less very similar across varying disciplines.
Yeah.
And if you have those strong concepts in your first year, which is when most students join competition teams, you can expand and like work on pretty much anything, because it's just from that point on passion to learn and the motivation to keep working on these projects. So in fact, I've learned so many concepts by working in the team before I got to learn them in the classroom, and in fact they helped me do well in exams.
Right.
So in that sense, you do really get to learn and expand your toolkit by working in a team like this. And it really prepares you for the world outside and the world beyond once you've graduated. Be it building your own startup, or be it working in a corporate environment and like helping to excel that company forward, or maybe you go into research and you become a professor in a particular field. The expertise and the experience that you gain here is going to be invaluable regardless of what you end up doing.
That's a very interesting point. I want to say that my personal opinion is that students should do what they love, and
Yeah.
careers will take care of themselves.
Yeah.
But I do understand when somebody asks, or when somebody wants to know, and I'm representing those people now, does working in these student teams, and obviously it's a lot of work, it's like 90 hours a week,
Yeah.
or more, right? Does working in these teams help you in getting a better postgraduate entrance, or does it help you get a better job? What kind of companies does it give you an edge on? And be frank, like
Yeah. Oh,
take names.
okay. So I could take myself as an example for this. In fact, like the intern I had an internship at a FMCG company last summer, and FMCG is probably not very related to the work that we do here. But it I'll
FMCG is
experience
like
that you-
Unilever, ITC,
yeah,
Marico.
exactly.
Yeah.
So it's fast moving consumer goods.
Yeah.
And it's all about production and manufacturing and optimizing things to reduce costs and like do things more efficiently. And I don't really do that exactly over here, but I'm working on a prototype vehicle where I'm trying to optimize other things, like say the mass of the car, or like help improve performance. And by doing these things, you learn certain concepts that can help you regardless of where you go to. And so for me, I found sort of acing the interview and acing all the selection processes for this to be very simple and straightforward. Whereas you have a lot of other people
Understand.
who might have had to put in a lot of time to prepare specifically for this, whereas I did not have to.
Sure.
And similarly in the placement process, or we have so many teammates who've gotten into research internships, or who've gotten through their placements so much more easily and so much more, they've just had an edge. Like you have a project like this on your resume, and you have a company who comes and looks at this, and they've seen that you've been building something like this for say the past 3 years, they're bound to be impressed. Like this is something that not a lot of it's something that's very unique to sort of CFI and in IIT Madras, like the exposure and the resources that you have here to sort of do something like this right from the very start, from your first year.
Right.
You have it in other colleges, but probably not at the scale that it exists
For
in
sure, for
CFI.
sure. Or maybe an NIT or something else may have a fewer number of clubs or a fewer number of these things, and maybe their funding will be a few less. And here it's more, and
The support that you get from faculty is for sure going to help you a lot as well. So yeah, I think
So you're saying that the 10 to 12% of students who are involved in CFI clubs, they have a slightly better edge in their interviews because the interviewers recognize you for the work you've done. For sure. And second is that you are able to answer questions in a better way, in a more.
And again, this of course it gives you a massive edge when you're applying to a role that's relevant to what you've done, because you have a unique experience here that no one else in the campus probably has, or maybe in other campuses probably has. So
Sure,
these
if you're applying to ASR, then
yeah,
there's
for
a
sure.
edge.
Yeah. So in that sense, it gives you a significant edge. But then even when you're applying to, even you're branching out to say other things, there is still a decent amount of an advantage that you get from working on a project like this.
Understood. Okay, I want to ask you a question about the lows.
Yeah.
In the sense that in this podcast, we often talk about what got achieved, what are the achievements, where did you place, podium finish, etc. But of course, a lot of engineering is about facing failure, because when you're working with engineering systems, right, and they're brutal. If your car crashes, it'll break.
Yeah.
If it's not like go to ask you.
Yeah.
So what are the lows that you've gone through or your team has gone through, and how do you deal with it?
So, like you mentioned, engineering is a very iterative process. You're constantly learning from the mistakes that you've made, and you're constantly getting better at these. And we have, so over the past 2.5 years, almost 3 now.
What's the most spectacular failure
Okay, the most spectacular failure. So, from my time in the team, I would probably say, this was 2022, no, 2023 January, and we were going to launch our first ever electric race car for the first time. We had just worked, this was 2 years of hard work that had gone into this during the COVID pandemic, and then another half a year of like manufacturing and putting it together. And we were going to launch it at HFC, it was at Himalaya, at the launch. And we had everything planned, and we were like 3 days away from the event, and we were testing the car for the competition. And we were testing it around NAC, and in the middle of the night, well, the car crashed, and we broke like the suspension on the right side of the car. It was like completely gone, and it wasn't in a presentable state to launch it. And we just had like 3 days to put it back together somehow. And the worst part was that it was a weekend the next 2 days. So all the manufacturing shops, everything's going to be closed. We had like the entire team had to scramble. This was a low, but then the best part about the team is that no one ever gives up. Like regardless of how bad the situation is, everyone just gives their all, and it motivates you to be even better and like push even harder. We pushed non-stop for those 3 days. We went and we forced these shops to stay open over the weekend and like make these parts for us. And everyone was scrambling. Everyone knew what they had to do, what their responsibilities were, and everyone made sure they did their part. And we managed to get the car back together, and we launched it fairly successfully. We got very good reception as well. And I think it was a success. And in that sense, we always have these lows, and they're always transformed into like highs at some point. And that's like the joy of like working in a team like this. You have constant ups and downs, but then the lows, like the highs are worth wading through the lows and like pushing the team back up. And in that sense, it's always nice when everyone gets together to like work towards one common goal. It's always nice to see.
Nice.
Yeah.
I like that phrase. No one ever gives up. It's beautiful. Okay. Thanks, Ankit. That was great. Who are we meeting next?
We are meeting Divyaratna Joshi. He is a junior electrical engineer in the team.
Yeah, so I'm Divyaratna. I'm a third year undergraduate in chemical engineering, and I work on the powertrain side of things in Raftar.
Okay.
So it's most like in my year right now, it's just mostly managing my juniors. We call them sub juniors. I'm a junior engineer, and it's mostly managing them as well as designing what the next year of the car will look like in terms of a powertrain. So that's low voltage, high systems, high voltage systems, motor control, etc.
Can we walk this through? How did you join the team? Did you join it in your first year?
Yeah, so the team generally recruits in the second sem, and that's because unlike other Formula student teams in India and abroad, we'd like to get the students on with the process as soon as possible. So second sem we have an application process, post that an interview, and then finally.
Okay. And when you joined first, what were you working on?
So when I just joined, how it works is that like it's completely foreign to me, right? So a good way of getting juniors up to speed is to get them to do sub-junior projects. So basically, small tasks that teach them basic functionality of the entire car. I'm talking more of from an elect perspective. In the mech side of things, they just understand.
Wait, hold on. You're a chem engineer who's working on elec.
Yeah.
Is that
so
common?
That's very common. So in fact, ironically, we have electrical engineering people working on aerodynamics and fluid flow. So that way it's interdisciplinary. It doesn't really matter. I was passionate about electronics since my school years, so it just made sense for me to join there.
But when you joined and you entered your choices, didn't you choose if you were passionate about electronics already, wouldn't you have chosen an electronics course instead of a chemical course?
While true, I did put that at a higher priority. I mainly joined because of the campus. So my bigger priority was choosing IIT Madras as a campus over probably a branch, because like I had seen probably like a few videos and some articles about how like this. I saw C5 basically.
Okay.
And that kind of made me realize that it doesn't really matter what branch I'm from, at least here, as long as I'm willing to work towards something that like.
That's damn cool.
Yeah.
So you wanted to join for CFI, you joined CFI, and then you worked in CFI.
Yeah, so it was like a dream come true.
Oh,
In a way.
Awesome. I'm going to ask you, you drive the car.
Yep.
So how does that part work? Because all we've been hearing about is design, business plan, cost, etc., etc. But there's a actual driving.
Right. So in the end, it's a race car, and in the end, there's also a race. So the way it works is drivers are recruited from the team itself, and that's a mandatory part of the competition rules. And so we have 4 drivers, myself, Ankith, who you just interviewed, and 2 of my other batchmates. And so the way it works is that we have driver selection just before our competition, and we assign the drivers to basically third years. We don't let the first years drive because there's a lot of there's too much enthu.
Okay.
It's a responsibility to be driving that car.
Yeah.
And so yeah, we have driver selection for drivers, and I think the reason why the team members drive is because it's very important that with design comes validation. So as, let's say, a powertrain engineer, I'm working on motor control on the low voltage systems. When I drive, I can gauge how effective my controls are on the car.
Sure.
Or as Ankit, who you just sent
And how fast do these cars accelerate, and what are the top speeds like?
Oh, so the top speeds for this car is 154 kilometers per hour. And we mainly focus on acceleration. So we go 0 to 100 in less than 4 seconds. That's faster than your Ferraris. So that way, yeah, we push the limits for an electric car.
Interesting. And have you had like accidents or anything?
Yes. So, like I said, it's a responsibility, right?
Sure.
It's the dreams of 40 people behind your wheel when you drive. And so, just in NAC a few years ago, just outside Seafair, one of my seniors, he spun out because there was a lot of these throws aren't meant for speeds, right? There was a lot of dust on the road, and so he just did a spin out and he hit a tree. And in fact, if you go there and in front of NAC right now, there is a chiseled out part of the tree, and what that led to was half of the front of the wheel assembly completely detaching from the car, and it was just it was an overnight push to get all of that working.
But in during a competition, you've not had a crash. But is that common at all? But one second, I want to ask you: in the competitions on the track, do you all race together, or all the races they drive together? Or is it
So again, so the competition has multiple events. Only in one of the event called endurance, which is the longest race, 5 teams drive at a time. They are not wheel to wheel racing. So let's be clear. There's no competition of I have to get ahead of that guy. It's everybody's running for their own time. So in the end, what matters is stop minus start. That's my time for the event. However, there are overtaking zones. It's still a student competition. Nobody's a certified driver technically, so they would not want to kill anybody.
Yeah.
So yeah.
Yeah.
No crashes though.
Okay, cool. How it's interesting because obviously this involves a lot of work.
Yeah.
And how do you manage, or how do students in your team and other CFI teams also, how do they manage your academic workload? Plus, maybe some of you are interested in sports, or maybe you have some cultural thing that you want to take part. Maybe somebody dances, somebody writes.
Right.
I don't know. How does that work?
So it's honestly just about time management. We see in most of our courses across the board, we have quite a lot of free time. Given that the campus allows us to have 40% of our electives decided by ourselves, we pick slots as well as credits. We kind of switch around credits in a way that we end up saving a lot of time for Raftar. So, for example, me, I would say that I can come back from my academics, which is right now it's barely 4 classes a day. So it's completely flexible. I come back, I can do my Raftar work. I play squash. We have people from my team going for inter-IT sports, which is probably the most taxing in terms of time. We have people from culturals, from tech. So honestly, time balance is not that big of an issue. You do have to push sometimes, come closer to the competition. You might have I was in campus for most of my winter vacation. So there is a bit of sacrifice, but again, it's just passion. So
Sure, fair enough. You're at the very least you have to sacrifice your holidays.
Yep. But it's worth it.
Nice, damn cool. And do you feel that I'm sure you have friends because you live on campus and it's a residential.
Yeah.
You have friends who probably chill a lot more than you do or your teammates do. Do you feel like overstressed, or does it feel like it's too much?
It sometimes does, like, obviously. I would say sometimes there is quite a bit of stress, especially coming closer to the competition. There are deadlines. I think Aryan went over the different events and static events, especially, that happen. So there are a bit of deadlines, but overall, I would say the way a team bonds, especially in C5, given that we are working together every day as compared to, let's say, another peer, it's worth it. Like, the validation.
How do you manage that kind of stress level? And you're just like 20, right? I don't know.
Yeah, 20. Stress management.
Okay, I guess you're still learning. This is damn cool. What are the plans for the next few years?
For the next few years, right? So we've kind of established ourselves very well in the Indian field. So I see us going more and more to match level up with the international team. We're still quite a way. That's one thing. And second is to be able to, for that to happen, we need to raise money. So a big part of what we're focusing on right now is getting more and more sponsors, because our work right now, our goal for, like, let's say 2027 is to go to be the fastest electric autonomous vehicle in the world, period.
Okay.
And that's ambitious, and that requires money. So a big part of it is going out to companies, especially for industry collab, where we see ourselves not as someone you can donate money to.
Yeah, that's an interesting thing. I get why the institute would support this. I get why you participate. Why will someone sponsor your? What do they get?
So we are, like I said, we're trying to move away from more of a CSR team where people just dump their funds on us, and try to be something of value to other companies. For example, we've been collaborating with MRF for the past, I think, 5 years. They actually used to give us tires, and what we would do is we would hook them up with an array of sensors, take them to a test track, just belt them till they are gone, and give them the data. And what that would help them do is analyze how their tires behave at higher speeds, at higher temperatures. Then they would manipulate that compound and send the tires back. So MRF actually started an entire category of Formula student tires specifically for these conditions, based on the data that we give them. So it's more of like a two-way thing. We collaborate with them, help
So in
them.
some you're saying in some cases the company sort of, maybe not in a big way, but at least in a small way, gains something by working.
Exactly. Yeah.
So those will be the top kind of companies who sponsor.
Exactly. So we were also in fact working with Daimler. Daimler is the parent company of Mercedes-Benz, and they wanted to come into India to set up their own electric powertrains. So we helped them design a test bench with us. They worked it out.
Nice. And then second category would be alumnus or companies which want to sponsor you for a CSR.
Yes.
Kind of.
Yeah. So that would include basically all the CSR donations that happen. And thankfully, we have alumni in very senior positions in a lot of companies. So it's a lot about contacts, right? So that way we get where we want.
So can you say that again? By 2027, what?
By 2027, we want to be the fastest electric autonomous vehicle in the world, period.
I think that's a good place to stop.
Yeah.
Okay, thank you, Divya, and my gratitude to Ankith and Aryan for sharing this with us. That's the podcast, guys. Please like, follow, subscribe, and if you guys know the Raftar team, then comment or share it with your teammates. Thank you.